The average speed of a runner in 400-meter race is 8 points. So the race is 400 meters. So the distance here is the 400 meter. And we are told that the average, V average, is equal to 8 meters per second. I think this question, almost everybody got this right. Okay, how long did it take the runner to complete the race? So clearly the question demands a time. Okay, it demands a time. So V average is equal to total distance over the total time taken. And so the total time taken made as a subject will be equal to total distance divided by the average velocity. And so 400 divided by 8 must give us 50 seconds. And that is the answer. So the answer is the second one, or B, and almost everybody got this right. Question 2, which graph best, so this is 1, this is 2. Which graph best represents the relationship between velocity and time for an object that accelerates uniformly for 2 seconds, then moves at a constant velocity? So if I want to sketch this motion graph, a quick sketch. At least for the benefit of those who could not join us when we treated it. This is speed and then time. We are told that, so which graph best represents the relationship between velocity and time for an object that accelerates uniformly for 2 seconds? So within 2 seconds, we are told it accelerates uniformly, then moves at a constant velocity for 1 second, additional 1, so totaling 3. Let me expand the time something a bit so that the graph will be more clearer. So assuming this is 2 seconds, 1 minute for that constant, making 1 second for, then then moves at a constant velocity for 1 second, and finally decelerates for 3 seconds. So 3 plus 3, this will end at 6. Okay, so supposing the velocity is V, we're not given those details. And we were also not told that the body starts from rest. So we cannot start our graph from this point, from the 0 point, because the question never told us that the body starts from rest. So once we are not told, it means there is a certain initial velocity. Okay, so it accelerates uniformly for 2 seconds. So from initial velocity to this point. And don't forget, this point must go with the time. Then maintain the velocity. So constant velocity for 1 second, or it must also represent the time mentioned. Then finally decelerate for, and here too, we're not told that it decelerates to rest. So we cannot end here, but we are told it decelerates for further 3 seconds. So we can only end here. And now this thing cannot touch the time as is because we were not told that it's decelerate to rest. So obviously, when you look at the graphs, clearly the first graph is right. Class, are we fine?
Yes, sir.
Okay. Then question 3. Question 3, yes. The graph below represents the motion of an object traveling in a straight line as a function of time. What is the average speed of the object during the first 4 seconds? So we are looking for the average speed during the first 4 seconds. Okay. I'm going to guide you to answer this question of during the first 4 seconds. Then I create another one for you. Now, this is when you are given the graph, the first thing to look at is the kind of graph. Is it velocity time graph? Is it displacement time graph? Obviously, this is a displacement time graph. So the graph starts from 0 when velocity is displacement is 0, then goes through a uniform velocity within period of 2 seconds, then remains stationary for additional 2 seconds, and then continued its motion in the opposite direction. Okay, continued its motion to a displacement of 1 meter in the opposite direction within a time interval of 1. So what is the average velocity? Okay, during the 4 seconds. We know V average is equal to total distance divided by the total time taken. What is the total distance during the first 2 seconds? During the first 2 seconds, it covered a distance of 2 meters. So from 2 seconds to 4 seconds, the body remains stationary. So its distance covered is 0 divided by what is the total time for all these motions? 4. So we have 2 on 4, which is equal to half, 0.5 meter per second. So, ladies and gentlemen, in case you got this wrong, this is the right way to go. Now, the question to the house is that, can you help me determine the average velocity during the whole 5 seconds of its motion? So during the 5 seconds of its movement, what will be the average velocity? 1 minute, within 1 minute. Within 1 minute. Just do it and share your answers with me. What is the distance, average velocity during the whole 5 seconds of its travel? Yeah, who has finished? If you've finished, please share it with me. Oh, 1 minute. Oh. Farida. Farida is not talking, meaning she hasn't completed it. Okay, let me call Miraculous. Miraculous. Inshira Kwatima, what's your answer? Inshira Kwatima. Oh, Inshira is receiving the benediction. Okay, the gentleman. Who is true? Alvin. Hey, everybody seems to be asleep. Okay, so what is the average velocity during the whole 5 seconds of the body's motion? So from 0 to 1, the distance covered is 2. From 2 to 4, the body remains stationary. From 4 to 5, the body covered a distance of 1 minute, 1 meter in the opposite direction. Total distance. We don't care about. Yeah, Ishra Minta.
Sir, please, it was a mistake. Sorry.
But what's your answer, Minta? Okay, Francis. Francis, what's your answer?
I got 0.6.
0.2.
Yes. So you have 3 divided by 5, which is 0.6 meter per second. Okay. So it's not so difficult. Question 4. Which statement about the movement of an object with 0 acceleration is true? Please, if a body is not, if a body has 0 acceleration, it only means that the body is moving or traveling with a constant velocity. In fact, we cannot talk about acceleration when a body is stationary or at rest. What did I say, class? What did I say?
We cannot talk about acceleration when the body is stationary.
Exactly, because acceleration is change in velocity or speed of a body with respect to time, meaning the body must have speed or velocity, and the velocity must be changing before we can talk about acceleration. So if a body is stationary, we don't even talk about acceleration because it has 0 speed. So which statement about the movement of an object with 0 acceleration is true? 1, the object must be at rest. This is a no, no, no. 2, the object must be slowing down. 3, the object may be speeding up. And 4, the object may be in motion. You see, 1 is a no-go area. You need to talk about it because I just said it. Because the body is at rest. Then 2, the object must be slowing down. If it is slowing down, then the body is decelerating. The acceleration won't be 0. Then 4, the object may be, 3, the object may be speeding up. If it is speeding up, then it means it is accelerating. The acceleration won't be 0, but will be positive. The object may be in motion. Yes, the object may be in motion because for 0 acceleration, the body is in motion, yet its velocity is constant. So if it has 0 acceleration, the body may be in motion or must even be in motion for 0 acceleration. So the answer is the 4th one. Then which graph represent an object moving at a constant speed for the entire time interval? Constant speed. We've done this. 1, the body is stationary. 2, the body is moving with non-uniform distances being covered. And so the velocity wouldn't be uniform along the curve. 3, the body moves with a uniform speed for some time and then stays stationary throughout. Then 4, it has that uniform velocity. So the answer is 4. Okay. Then 11. Acceleration is a vector quantity that represents the time rate of change in velocity. 12. A moving body must undergo a change of for a body to be said to be moving. The evidence of it is that we must see a change in its position. Acceleration can be 0. The speed can be constant, but the position must certainly change. So 3. Then question 13. This I'll quickly sketch a graph because I think there were lots of confusion. So I'm only ruling the 4 vertical lines. Then we have 1, 2, 3, 4, 5 horizontal lines. Good. This is 0, 2, 4, 6. Along the vertical, we have 5, 10, 15, 20. Okay. We just create an extension of this. This is 25. Now, the motion of the object A starts from rest, passes through 15, and then ends somewhere here. That of B also starts from rest, passes through 5 and 10, and ends exactly here. Class, are you with me?
Yes, please.
So this is A, this is B. Then the question asks that the graph shows the relationship between speed and time for two objects A and B, compared with the acceleration of object B. The acceleration of object A is, so when you compare the acceleration of object B to acceleration of object A, what will be that relationship? So it means that we first determine the acceleration of A and B and draw the conclusion. This is a speed time graph. Speed time graph, and the slope of a speed time graph is equal to the acceleration. Now, look at where A is. A ends here. We cannot pick, in finding the slope, we only determine 2 points along the straight line, and the value will be the same everywhere. But we can hardly read the time to this point. So we'll only pick this, the starting point and this point instead. We'll pick the starting point and this point for our slope, because with this we can easily find the speed and then the time as well. So acceleration of A is equal to the change in the vertical. The vertical, we have this. this side. 15 minus 0. 15 minus 0 divided by 2 minus 0. And this will give us 7.5 meter per second squared. Emmanuel, quick
Sir.
one.
Why the minus 0?
Oh, we are looking for the difference between this point and this point, change in the vertical. Okay, so the difference between this point, don't forget that we can read this change in the vertical with the maximum value will be here, and then the minimum value will be on the 0. So if you are looking for the difference between this, then you must subtract this point 0 from 15. Emmanuel, are you okay?
Yes, sir.
All right, then acceleration of B. We pick any 2 points. For B, we can take any 2 points. Okay, we wouldn't care about how because it is uniform. So if we pick this and this, if we pick 0 point and this point, I'm coming. All right, the change in the vertical here too will be 10 minus 0 delta V. Emmanuel, are you okay as to why it is 10 minus 0 this time around?
Yes, sir.
Okay,
yes,
divided by 4 minus 2. 4 minus 2. And this is also giving us 10 over, oh, sorry, 4 minus 0 rather. It's not 4 minus 2. 4 minus 0. So this is also giving us 10 divided by 4. And 10 divided by 4 is equal to 2.5. 2.5 meter per second squared. Now, if you divide velocity of B by velocity of A, this will give you 3. 7.5 divided by 2.5 is equal to 3. Ima?
Sir, please, I have a question.
Go ahead.
Sir, please, can you ignore the 0?
Oh, you see,
The minus 0.
you can pick, you can ignore it, okay, but sometimes it wouldn't be 0, so you shouldn't always be seeing it as ignoring it. You can ignore it because this time around it is 0, but if it is not 0, you cannot ignore. Okay.
Okay, sir.
So because the ratio is this, then we can say that velocity of A, when we compare it to the velocity of B, V of A is 3 times as a velocity, acceleration. It's 3 times the acceleration of B. Okay, here the emphasis is on compared with the acceleration of object B. The acceleration of object A is 3 times B. If it's the other way around, then it would have been 1/3 as the velocity of A. So that is how come our answer is 3 times as great. Velocity of acceleration of A is 3 times as great. Please, those of you who got this session wrong, are you okay?
Yes.
Or they are not here. Okay, let's move on to the next question. Question 14. 14 is also a graph kind of a. What is the acceleration of the object during the time interval t is equal to 3, 2, t is equal to 6. If you have a velocity time graph, the slope is equal to the acceleration. So here, looking at the time interval, t is equal to 3 to t is equal to 5, it goes with the slope CD. So find the slope CD, and that will be equal to the acceleration there. So slope CD would be equal to the change in the vertical, the maximum velocity at time of 5 seconds is 25. So 25 minus velocity at 3 is 10, divided by the time interval, which is 5 minus 3. And this is 15 on 2, aka 7.5 meter per second squared. Then question 15, what is the average speed of the object during the time interval t is equal to 6 to t is equal to 8? Average speed can be determined in 2 different ways. Initial velocity plus final velocity divided by 2. And we're given the time interval 6 to 8. So determine velocity at time 6, and that is 25. Velocity at time 8, that is 10. Divided by 2, you have 35 on 2. 35 on 2 is 17.5 meter per second. Another way of determining the whole thing is this. Look at the shape, okay, between the time interval 6 to 8. You have this kind of shape. Lionel.
Yeah.
Uh-huh.
How come you got a 25 plus 10 over 2?
Oh, do you have the graph?
Yes, please.
Check, read on the graph, okay? You see, we're given the time intervals to 6 to 8. What is the velocity at time t is equal to 6? What is from the graph? What is the velocity corresponding to the time t is equal to 6? Lana, I'm listening. Class, what is that?
I'm not.
So no, if we are discussing and then you don't, use your graph, you'll be lost. So please pick the question, open it, and then use the graph to follow all that we are discussing. So the shape there is like this. Average velocity is equal to total distance over total time taken. And you have a speed time graph or velocity time graph. The area under it is equal to the total distance traveled, or yes. Okay, so let's find the area under this graph. And this area is the area of a trapezium that with the side A and then with the side B. This is the B side. Then we have the height perpendicular to both A and B, which is this. So H is this. Okay, so what will be the area of this trapezium will be equal to the distance covered. Half A plus B times H. From our graph, from the graph, what is the value of A? Class, from From the graph, what is the value of A? Yes, anybody from the graph, what is the value of A? Oh, class, from the graph, what is
10?
That is 10. Then what of B? Isaac, go ahead. Wilson.
25.
25. What about H? What about H? What's the value of H? Isaac?
2.
That's
please, 2.
Good. So this and this will cancel out. When you sum up the two values within a bracket, you have 35. So the total distance covered is 35. Okay, therefore average velocity will be 35 divided by a total time of 2. The value is still the same, 17.5 meter per second. Yes, meter per second. Are we okay? Lionel, are you okay? All right, so the next question, please, if you have any question, quickly ask before we continue. 16. What is the total distance traveled by the object during the first 3 seconds? And I was shocked a lot of you got this part wrong. What is the total distance traveled by the body during the first, yes, 3 seconds? If you look at during the first 3 seconds from 0 to 1, 2, and 3, the shape is also the shape of a trapezium. The shape is like this. Okay. This is 1, this is 0, then ends at 3, 2 is here. From the graph, this part links to a velocity of 10. So if you have to find this area under the graph, the velocity or speed time graph is equal to the total distance. And so I was surprised to see a lot of you getting this part wrong. So total distance is the area of the trapezium, which is half A. Here A is equal to 3 minus 1, 2. B is equal to 3. And H, which is this, is equal to 10. So we have 2 going into this, 5. When you sum up the numbers in the brackets, you have 5 times 5, which is 25 meters. So obviously the correct answer there is the third one, 3. A lot of you chose 30 and all that, which was quite disturbing. Emmanuel Teria.
Sir, please, I wanted to ask that, can you do it bit by bit? You
can. It must give you the same value. Let's look at your the bit by bit approach you are asking of. You see,
okay,
this
sir,
part would, okay, this part is a triangle. Okay, so
yes, sir.
Finding the area of the triangle will give you the distance traveled during from 0 to 1. So from 0 to 1 second, you have half times the base, which is 1 times 10, giving you 5. Then from 1 to 3, you have a rectangle, area of a rectangle. Okay, length, which is 10, times the breadth, which is 3 minus 1, 2, totaling 20. When you add the two, the value is still the same. So you can break it up. And it's true. Sometimes the shape can be such that you cannot tell. So the obvious way to look at is to break it down. Okay. Okay. 17. During which interval is the object acceleration the greatest? This one too, there were lots of issues because some of you only looked at the face value. You saw the graph and thought that CD is steeper than AB. Okay, you can do that judgment when they all start from a common point. But if they don't start from a common point, if they had been like this, AB is here, AB, and then perhaps let me clear the red and then use blue. Then perhaps CD. CD was also from the same 0 point. CD is somewhere here. Then you can just use visual judgment. You can judge it with your eye and then answer. Because when you compare this way, then it means this CD here is more steeper than AB. But when they don't start from a common point, please calculate the slope. So if you calculate the slope of AB, you have 10 minus 0 divided by 1. 1 minus 0. So clearly the slope of this is 10. Okay. If you look at CD, you have 25 minus 10 divided by, changing the horizontal, 5 minus 2, which is also 15 on 2. Sorry, 3. 5 minus 3. So 15 on 2, this will also give you 7.5. So it means that AB has a greater acceleration than CD. Okay, so the answer is A. Are we okay?
Yes, sir.
Yes, sir.
18. 18. During the interval t is equal to 8 to t is equal to 10, the speed of the object is, so t is equal to 8 to t is equal to 10. You can see that the body is going through uniform deceleration. So uniform deceleration also means that the speed is decreasing with uniform time. So the speed is decreasing 3. Yeah, a lot of you got that correct. And 19, what is the maximum speed reached by the object during the 10 seconds of travel? So during the whole 10 seconds of travel, what is the maximum speed reached? From the graph, from 0 to 10, the maximum speed reached is 25. Okay, it started from 0, then accelerated to 10, then maintained the speed for 2 seconds, then accelerated to 25, from there maintained it, then decelerated uniformly back to 10, okay, and then decelerated uniformly to rest. So the maximum velocity range during the whole 10 seconds of travel is 25. So simple. But a lot of you also did well. I got 14 over 14 there. And some of you, I even gave you further questions. So please, if you want me to still challenge you with questions pertaining to graphs after class, send me a hi and then remind me. I'll give you similar challenging graph works just to help you master the concept. Is that clear, class?
Yes, sir.
Just give me a
Yes,
minute
sir.
to take attendance and get back to you. As for questions, when you ask, I can give you a lot of them. Brain twerking questions. Okay, so feel free, and then if you want to practice, contact me.
Sir.
Hello.
I
I'm
thought you were
just,
disconnected. Sorry.
no, I'm just taking attendance, so I'll be with you in a minute time.
Okay, sir.
Yes, I give this question, I uploaded it on a page today. I want you to quickly use about 4 minutes to do this for me. It's a simple question, but I want to see how best you can apply. There were a lot of questions, but yes, this one, let me repost it on the page. Yes. Jill walks at a constant speed. Jill walks at a constant speed to her friend's house 120 meters away in 60 seconds. Jill walks at constant speed to her friend's house 120 meters away in 60 seconds. After talking to her friend for 30 seconds, she returns home at constant speed in 40 seconds. Using the information, I plot a distance time graph for the motion. I plot a displacement time graph. Don't forget, displacement is also position. So plot a displacement or position time graph of the same motion. Class, I want you to try this for just sketch. Please sketch. You are not supposed to use a graph, just a sketch of the motion. The distance time graph and then the displacement time graph of the same motion. And you must use about 4 minutes to do this. Start work. Start work. I'm timing. Right after 4 minutes, we'll discuss it, where I'll solve it with you for you to be doing the marking. So start work. Those of you who couldn't get the first assignment correct, if you were not able to get everything correct, please you send corrections to me for marking, okay? So those points or questions you couldn't get after discussing, you should be able to redo it, send it to me for marking as correction, okay?
Say,
Hello.
so please, my network was breaking, so I didn't hear the
So
instruction you gave about.
I've given you a question to try. So I'm reading. Okay, I'm
Say,
going
please, I
over.
have
Just
a question.
the jail question.
Yes, please.
Okay, I said that those of you who couldn't get everything right in the first assignment, send corrections to me for marking. Okay.
Your question, when we are done solving, should we send it to you through the assignments creation, the assignments platform?
Exactly.
So please, what if you had everything correct? The
Oh,
first
if
one.
you had everything correct, kudos to you. Okay. I was only referring to those
Okay,
who
sir.
couldn't get everything right.
So is it like from the whole work or the one that you solved so far?
No, the one we just discussed.
Okay. So please, that part had everything correct.
Then it's a feather in your cap. Okay. You
Okay, sir.
have no problem. I'm listening.
Sir, please, can you repeat the question?
Okay, so the question is actually on the page. Oh. I forwarded it to the page. Jill walks at a constant speed to her friend's house, which is 120 meters away in 60 seconds. Jill walks at constant speed to her friend's house, 120 meters away in 60 seconds. After talking to her friend for 30 seconds, she returns home at a constant speed in 40 seconds. Using the information, plot a distance dash time graph for the motion. Then plot a displacement or position time graph for the same motion. Okay. So you are providing two graphs, distance time graph and displacement time graph. I gave you 4 minutes. You have 2 minutes now. Just a sketch. or distance, time is always an independent variable, so it must be on the horizontal. So she covered a distance of 120 meters to the friend's house, after talking to her friend for 30 seconds, she returns home. So in all, Jill covered a distance of, Jill covered a distance of what? Class, in all, Jill covered a distance of
60 meters.
Hey, read a question.
240 meters.
240. Jill walks at a constant speed to her friend's house.
120.
So she walked 120 to their friend's house and then returned. So in all, she covered a distance of 240. 120 times 2, because she returned. So 120 to the friend's house and another 120, totaling 240. So she went through uniform velocity. So let's indicate where the distance and then the time would intersect. So the slope is the uniform velocity. Good. Then when she got there, she talked to her friend for 30 seconds. Within the 30 seconds, Jill was stationary. So it must show 0 slope. So this is the point where the conversation ended. It also ended here. After which Jill returns home. And Jill took 40 minutes to walk back home at a constant speed. So this must also, let's determine the point where the distance and then the time will intersect. And that is where the distance ended. Good. So class, this is the distance time graph of Jill's movement. How many of you got this correct? If you got it right, let me see you. Okay, all right. Good. Or mark yourselves. Okay, if you got it right, mark yourselves. Then let's look at the displacement time graph of the same motion. So this time,
Sir,
distance. Hello.
sir,
Hello.
please, can you go over the distance time graph again?
Okay. You see, so
Thank you, sir.
distance has nothing to do with direction. For distance, you are looking at the totality of that length, okay, covered. So within 60 seconds, she moved from her house, covered a distance of 120 meters to the friend's house. Then when she got there, they spoke for some time. They spoke for 30 seconds. So 60 plus the 30, totaling 90, meaning this is where the conversation ended. It ended here. After which, Jill walked back home with a constant velocity and she took 40 seconds. So 90 plus the 40, that is why the time is ending at 130. So she further walked, okay, 120, moving from the house to the friend's house, she'll cover the same distance. So 120 plus another 120 will be the total distance. So this is the distance time graph. Then the displacement. For displacement, we care about direction. So she went to, let me indicate the times. So 60 plus 30 plus 90, we have 130. So when she moved from home to the friend's house, she covered a distance of 120. So this 120 displacement must be there. So the slope will determine the uniform velocity. Good. So she's now at a friend's house. She has covered a distance of 120. And let's connect that on a graph. A distance of 120, there's it. Corresponding to a time this. Then, after talking to her friend for 30 seconds, so 60 plus 30 is 90. This is where they talked for that long. And during the talking, displacement is 0. There wasn't any movement. So the displacement is 0, meaning the slope must be 0. After which, after talking to her friend for 30 seconds, she returns home at constant speed. For displacement time graph, we are always interested in the direction. So she moved from home to the friend's house in this direction. Okay, and from the friend's house, she's returning home in the opposite direction. So that will also be, okay, in that opposite direction. So the motion touches the time axis. When the motion touches the time axis, it means her displacement is 0. So I'm creating an arrow to indicate that she's returning back to a starting point. So when, at this point, meaning within a time interval of 40, the displacement on the vertical axis is 0. So this is a displacement time graph, and this is the distance time graph of gel. Please, is there any question? Is there any question? All right. If there is no question, then let's continue our discussion on. We derived the equations of motion. Can I flip to the next page, or you are not done sketching? Class, can I move to the quick one? Hurry up. So let's look at applications of the equations of motion. Applications of the equations of motion. Then we can decide to move on from tomorrow. In our last meeting, I think we derived all the 3 equations of motion. So let's see how that is applied in solving questions. And okay, so I'm beginning with this question. Please get ready to write the question. A body starts with an initial velocity of a body starts with an initial velocity of 26 meters per second and moves with a constant acceleration of 7 meters per second squared and moves with a constant acceleration of 7 meters per second squared for 25 seconds. Find the total distance moved in meters.
Sir, please, can you repeat it again?
A body starts with an initial velocity of 25 meters per second and moves with a constant acceleration of 7 meters per second squared for 2 seconds. For 25 seconds. A body starts with an initial velocity of 26 meters per second and moves with a constant acceleration of 7 meters per second squared for 25 seconds. Find the total distance moved in meters. Find the total distance moved in meters. So let's together try this. We are looking at using the equations of motion to solving problems. So we are told that a body starts, give me a minute, I'm coming. What is the initial velocity of the body? Class, what's the initial velocity of the body?
26 meters per second.
26 meters per second.
U is
26 meters per second.
okay. And moves with a constant acceleration of, the constant acceleration is equal to
7 meters
7
per
meters
second.
per second squared acceleration. And it's accelerated for 25 seconds. Find the total distance moved in meters. So we have 4 equations of motion. Equation 1. Yes, what is equation 1? Give us the first equation of motion. Yes, go ahead. Ajewa, go ahead.
V is equal to
Ajewa, speak up.
V is equal to U plus 80.
Good. The second equation of motion. The second equation of motion. Oh, let's Alexandra.
S is equal to
S is equal to UT
plus half AT square.
AT squared. Thank you, Alexandra. Let me go to the last class and call somebody who is sleeping. If you are sleeping, please answer. Okay, Zion, even though you are not sleeping, still answer. What's the third equation of motion, Zion? Hey, Zion is still sleeping. Abdurrahman. Oh, Abdurrahman, go ahead.
The third equation is V square equals U square plus 2. V square equals U square plus 2AS.
Thank you. Okay.
That's it.
All right. So when the question is given, look at what you were given and choose the right equation which you think can easily solve it. So looking at the information given to us from the question, which of these equations is appropriate to be used in solving? Will it be equation 1, 2, or 3? Which one? Respond it from wherever you find yourself, from your homes. Which of the equations do we use or must we choose to solve the problem?
Equation 2.
Okay, so Jedediah is going with equation 2. S is equal to UT plus half AT squared. Alexandra, what are you saying?
Equation 2.
Equation 2. Okay, so let's go with equation 2. So we have U. U is 26. T is 25. Plus half A is 7. Times 25 squared. S is equal to, what is 26 times 25? 26 times 25.
650.
650. Good. This plus square 25 and multiply by 7. When you finish, you divide by 2. That's 2,187.5, isn't it?
Yes.
Yes.
Yes. Okay, so add 650 to your results.
$2,837.5 meters.
Good. Now, we can also use equation 3 to do the same thing. We can also use v squared is equal to u squared plus 2as. But before we can use this, we must find v, because the question did not provide us with v directly. So we will use equation 1 to find v. So start work. Help me determine v using equation 1. Start work. You must finish within 2 minutes time. You are looking for v, which we will use in determining s. I've given that to you, so please do not sit on the fence. I'll call any one of you to answer. So, and I'm going through my list.
Please, which equation should we use to find v?
Oh, you see, in the third equation, we will need v. So use equation 1 to find v.
Okay.
Melchizedek, Moscow, Mavis, are you there? You should all be doing it, because I can call you at any time. Zion, I called you earlier. Zion, can you hear me? Okay, I can see somebody's. Okay, Jedediah. Jedediah, are you done?
Yes, please.
What's your answer for V?
201.
So let's see. You, there's another hand up, and that is Pascaline. Pascaline, what's your answer?
201.
Okay, so I think it must be around the same figure. So let's see. We have 26 plus 7 by 25. Davis, I guess you got the same thing.
Yes, sir.
Okay. All right. So 7 by 25, this is 175. Okay. So this plus 26, we have 201. Thank you for your contributions. So once we have V, then we can go ahead, use equation 3. So 201 squared is equal to U, which is 26 squared plus 2 times 7 times S. You make S a subject. So we have 14S is equal to 201 squared minus 26 squared. Class, help me find S. Quickly finish it and then give me the value of X. Camilla.
So please, the value of S is 2,837.5.
Okay. Okay, so let's wait for about 2 more people to confirm for us. Nanatre.
Sir, please, I got 2,837.5.
Okay, so you are confirming what Camilla told us. Odonko, is it the same thing?
Yes, please.
Okay, so we are getting the same results. Class, this is how we can apply the equation of motion. When you are given the question, you just look at it. And can we quickly plot this information on a velocity time graph? I want you to try sketching the information given to us on a velocity time graph. Start work. And we are going to, when you finish, we must also use it to get the same distance. Sketch the information on a velocity time graph. A body starts with an initial velocity 26 meters per second and moves with a constant acceleration of 7 for 25 seconds. Find the total distance moved in meters. And I said, sketch this on a velocity time graph. When you finish, we use this to find the total distance. And we must get the same figure, 2,837.5 meters. So let's confirm. Just a sketch. So a body starts with initial velocity of 26. So we must zero here, but we are starting from when the velocity is 26. Then we are told it accelerates by this margin. We had a final velocity to be 201. So there must be another velocity here, which is 201. Okay, within a time, so this acceleration from 26 to 201 took place within a time interval of 25. So let's assume 25 is here. So we start from this point, then accelerate uniformly within this time to the final good. So this is where the acceleration will end. We can clear this one so that our distance will end here. Okay, so the area under the graph would give us the total distance. The area under the graph would give us the total. Farida, did you get the same answer?
So I don't get it, how you plotted the graph. My network was misbehaving, so I didn't understand the...
So, Farida, listen to the question. A body starts with an initial velocity of 25 meters per second. So this is the initial velocity, 26. Okay. Then it accelerates uniformly. The rate of acceleration is 7. Okay, and it accelerated within a time of 25 seconds. So from when it accelerates by this margin, the final velocity we calculated it here, and then got the final velocity to be 26 plus this times the acceleration times the time taken. And so the final velocity is 201. So during the acceleration within the period, the final velocity is this, 201. And that's what I've indicated here. Friday, are you okay?
Please.
Good. So this is where it ends. So if I'm looking for the total distance traveled, the area under the graph would give me the total distance traveled. And what is the shape of the graph? What is the shape, class? What's the shape of the graph? Is it a triangle? Is it a rectangle or a trapezium?
Trapezium.
That's a trapezium. So when we find the area of this trapezium, we must have the total distance traveled. So help me determine the area of the trapezium. Half A plus B times H. A is this part, the two parallel sides, this side. This is A. And then B is this whole side. H must be perpendicular to both A and B. So this line, or this one, will be for H. Okay, so what A is 26 plus B is 201 times the height H. The height H is 25. Good. So let's put everything together and then give me the final answer. What's your final answer?
$202,837.5.
The same answer as we had. That's the beauty of what we are doing. All right. Is there any question? Ruby, Abdul Rahman.
Abdul. This is a mistake.
Okay. Another. Joel appear.
Sir, please, I got the same answer.
Good. Thank you. Another question for the house to try. We are looking at application of the equations of motion. An electric train moving at 20 kilometers per hour. An electric train moving at 20 kilometers per hour accelerates to a speed of 30 kilometers per hour. In 20 seconds. In a time of 20 seconds. Find the distance traveled in meters during the period of acceleration. Find the distance traveled in meters during the period of acceleration. Inshiraminta.
Sir, please, my network was unstable, so I didn't get the question.
Okay, I'll go over. During the period of acceleration. So I'm going over the question. An electric train moving at 20 kilometers per hour accelerates to a speed of 30 kilometers per hour. So this is the initial speed, and this is the final speed V. Okay. Moving at 20 kilometers per hour, accelerate to a speed of 30 kilometers per hour in 20 seconds. in 20 seconds. Meaning this acceleration happened within a time of 20 seconds. Find the distance traveled in meters during the period of acceleration. So give it, adapt it, after which we'll discuss it together so that in case you were not able to get certain things, we can correct it from there. Make me proud. And maybe six minutes to do this. Class, I'm timing you. Right after. Right after 6 minutes, I'll come your way. So there are some few tricks. Abdurrahman.
So I had 500 meters.
500 meters. You said you had 500.
Yes, sir.
Look at it again. Aram.
Okay, sir.
Sir,
Aram.
please, I had 139 meters.
Aram, look at it again. There are some few tricks. Your answer must. Okay. Russell, 138. Look at it again. Teria.
Sir, please, 166.67 meters.
Oh, okay. Russell, and I think another one of somebody also mentioned 138. Yes, the answer is 138.9. Ima,
Sir.
is that what you got?
No, sir.
Then look at it again. So,
okay, sir.
Russell, you got it right. And then I think Aram also. Davis.
Yes, sir. So I had
138.9.
Yes, sir.
Okay, that's correct. Darius, 138.
No, sir. I also got
You got what?
500 meters.
Then look at it again. All right. Then once the verdict is out, let's look at it, okay? Let's solve it together. Hey, some people are running away. The number is dropping. Okay, so the only trick in the question is that, Darius, we are solving it together. So let's we can all stop and then look at it together. The only trick in the question is that, you see, you are giving, whenever in physics, whenever you are giving quantities, and other quantities are not in SI units, other quantities are not in SI unit, you must convert them to SI unit, else your calculations will be wrong. So look, the initial velocity is in kilometer per hour. U is 20 kilometer per hour. V is also 30 kilometer per hour, all happening within a time interval of 20 seconds. And once these inconsistencies are there, and I think we're also giving the acceleration, or an electric train moving at 20 kilometers per hour, okay, we're not giving, good. So if we are to find the total distance, we can use either equation 2 or 3. S is equal to UT plus half AT squared, or V squared is equal to U squared, then we make S the subject. Whether equation 2 or 3, we will need the acceleration. So let's use equation 1 to find the acceleration. So A is equal to V minus U over T. Okay. It means that we must change U from kilometer per hour to meter per second, because meter per second is the SI unit. So 20 kilometer divided by 1 hour. Now, kilo is a prefix. After today's class, I'll send you charts of prefixes, because as disciples of physics, these prefixes must be at your fingertips. Kilo is 10 to the power 3. So if you give me 20 kilometer and I want to change it to meter, all that I do is to represent the prefix kilo, K, by its actual value, 10 to the power 3, and maintain M. By doing this, I've changed 20 kilometer to meter, and that will be 20,000 meter. Then I must also change per 1 hour, or divided by 1 hour, 1 hour into seconds. Okay, 1 hour is equal to 30 minutes. 30 minutes is equal to 60 seconds. And 1 hour is equal to 60 minutes. Okay, and 1 minute is also equal to 60 seconds, meaning that to change hour to 1 hour to seconds is just 60 minutes times 60 seconds. So that will be 3,600. So please, from today, science students, just in as much as you know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds, understand or learn by, knowing that 1 hour is also equal to 3,600 seconds. You should, memorize this, and then that would prevent you from that struggle in conversion. 1 hour is equal to 3,600 seconds. Okay. So we have 20,000. Yes, Farida.
Again, I don't understand.
Come again. You said you don't understand what?
How you got U is equal to 20 kilometers over 1 hour?
You see, 20 kilometer per hour. 20 kilometer per hour it means we have 20 kilometer. The per means divided by the hour means 1 hour. Okay, so 20 kilometer per hour means 20 kilometer divided by 1 hour. Right? Are you okay?
Please.
So that's how come I converted the kilometer to meter, hour to seconds. So we have 20,000 divided by 3,600, and that would reduce to 200 divided by 36. Class, give me 200 divided by 36 in 2dp. 200 divided by 36 in 2dp. Aram.
Sir, please, 5.56 meters
5.56 meter
meters per
per.
second.
Thank you.
Second.
Thank you. Then let's change the final velocity, which is in 30 kilometer per hour, into that. And that will also be 30 times 10 exponent 3,000 meter, also divided by 3,600 seconds. So that would also reduce to 300 divided by 36. Aram, what is 300 divided by 36 in 2dp?
Sir, 8.33 meter.
8.33 meter per second. And by doing this, we have converted everything into SI unit. Okay, velocity in SI unit, time in SI unit. So 8.33 minus 5.56, all divided by 20 seconds. Can you quickly do that for me? Can you calculate that for me quickly?
0.1385 meter per second.
Give it to me in 3dp.
Okay. 0.18139 meter per second.
Thank you. Meter per second squared. Okay, so once we have the acceleration, oh, the road is straight. We can now go ahead to drive at that top speed. Okay, so whether we use equation 2 or 3, we'll have our answer. So U 5.56, yes, the natural.
Please, so does that mean that every time we'll have to simplify?
I don't get your question so well.
Let me see. The velocity and the velocity.
Does that mean that every time we need to not simplify, but to convert to SI unit? Is that a question?
Yes, sir.
You see, we converted because, don't forget, the question said we have to calculate for the distance traveled in meters. Okay, so once you have to have the distance traveled in meters, if you don't convert and you use the velocities in kilometer per hour, in fact, you get your answers wrong. Okay, and as I said, whenever you are giving values and they are not in, or they are all not in SI unit, some are in SI unit, others are not, and you don't convert all of them to SI units and you work with them, it is wrong. Meaning, look at this particular, the speed is measured in kilometer per hour. Meanwhile, we're giving the time to in seconds. So if you don't convert, that inconsistency will be there, which in physics would definitely cause your doom. Okay.
Thank you.
All right. So let's calculate it now. We have 5.6 times 20. Hiram, what is 5.6 times 20? 5.56, sorry. times 20. I finished.
1.
Okay, then do calculate this one for me. 0.139 times 20 squared, all divided by 20, all divided by 2.
Sir, count down again, please.
20 squared. 20 squared is 400, isn't it?
Yes, please.
Good. So 400 times 0.139. Please, the rest of you must also be doing it.
75.1.6.
Please, sir,
400
we'll get 55.6.
Okay. Okay, all divided by 2. 55.6 divided by 2.
27.8.
Okay, 27.8. So add 27.8 to 111.2.
139.
139. Good.
Yes, sir.
Yes. You see, our 0.9 decimal place is missing here because don't forget in the acceleration I asked you to give me the answer in 3dp. Okay, and then during the conversion of the velocities, we express our answers in 2dp. These are what account for that drop in. So as the thing is that as if you have that large value of decimal places, the more you shorten it, the more you introduce error into your calculation. But it is always a big mistake if you are to write your values to 1dp, 2dp. In fact, at most, it must be 3dp or 4. Okay? Because the more you run it to the nearest decimal place, the more error you also introduce. Okay? So we don't encourage expressing decimal places to 1dp, 2dp, at least 3 and 4. Okay, so as to reduce the error margin of our final answers. Because we cannot be writing everything the calculator would give us. We cannot be writing everything. Please, is there any question? All right, tomorrow I would solve a more challenging question with you, about 1 or 2, so we wash our hands of this and then continue to another subtopic. Okay, so if you don't have any question, this is where we'll end today's meeting. If you have anything, please 1 or 2 minutes to ask quickly.
Please, don't you have any material to send it to us? Any material, any learning material? Like
you mean notes?
Yeah, notes.
Oh, but what we are doing is the notes. Oh.
Okay.
I can put materials together for you, but what we are doing, if you pay attention and then put some information down, you wouldn't require any other notes than this one too. But that notwithstanding, I will still put some information together for you. Lionel.
Thank
you. Lionel, quick one. Oh, it's a mistake. All right. So this is where we end today's show. Please upload the video, okay? If you go to the page, please subscribe to my channel and then share and then comment. Is that okay?
Okay, sir.
Okay. All right. Bye-bye.
Bye.
Bye.
All right. Hey, Darren, Komla, your hand is up.
Please open up your YouTube channel.
Oh, when when I send a link to the page, it will direct you to the channel, okay?
Okay.
So just hit on the channel or on the link and it will send you there direct. Okay, bye-bye.